Hello and welcome back again. This is Aditya. In this section we are going to take a look about IP operations. Since this is the part of CCNP 2.0 root, that's why we are going to discuss about this thing. So in IP operation we are going to take a look about ICMP unreachable and redirect, IPv4 and IPv6 fragmentation, and TTL, which stand for time to live. Now first we need to understand what is a ICMP, where it is used, why it is used. And these things which we are going to discuss shortly. So ICMP unreachable redirect and IPv4 IPv6 fragmentation and TTL, this topic may take more than one video to describe all about. But first take a look about what is a ICMP. ICMP stands for Internet Control Message Protocol, which is used in IP network for testing device reachability, query, and responding. And what is responding we're going to discuss shortly. And it working on network layer of OSI model, which is sometimes also known as 3.5 layer in terms of ICMP actually, because most of application they use to send data using TCP, either UDP. In case of ICMP itself going to send and receive data over IP network. So because of it not going to use any transport service, this is also known as a protocol which is working on layer 3.5. So ICMP used to send you reply or send you reply back if there is some kind of problem. So problem may be like the destination host is unreachable, destination network is unreachable, or the host may not actively working on particular port. So how you come to know by which means you are not able to access destination device? So ICMP going to describe using the different type of ICMP message. No matter when you're using ping, no matter you using any other application to take telnet or SSH or something else, it could be anything. Every time if destination is not accessible or not reachable, your ICMP going to inform you. It also going to tell you because of this reason, because of the device is not working on particular port which you're looking for, or device and the network which you're looking for is not accessible by your gateway. So we have couples of code and couples of ICMP type by which we come to know what is exactly problem. So at sending ping messages we use echo reply, which is type 0, destination unreachable, which is type 3, source quench type 4, redirect, and so on and so forth. We'll go through like line wise. We'll find most of things are use their own code like 0, 3, 4, 5, 8, 10 and so on and so forth. You can also use ICMP to get the information about link MTU, what is the maximum amount of data which can be transmitted on particular link or particular interface. So the tools which use ICMP like ping, traceroute, tracert, and path ping using different vendor like Windows, Microsoft, Cisco, and some other. So if you want to get more about all type of code, type of ICMP, you can follow the link which I have mentioned, I should say. So let's check. We have some kind of, this is the format of ICMP. We have some kind of type, some kind of code. By types in code, we come to know what is exactly reason. That's why we are not able to access the destination network. So in RFC, it is already defined, but there is lots of codes and type which I'm not going to discuss. So most commonly which is used in our network, some of our reserve actually, that we're going to discuss. So type 0, code 0, which basically means ICMP reply, and type 1 and type 2 are still reserved, may be used in future. Type 3 used to inform destination is unreachable. Since we know very well destination may be unreachable because couples of reason. The reason could be destination network is unreachable. Let's take an example. This is you and you may connect it to a router. Now router is a gateway for you that goes to connect with ISP or some other network. So the destination network is unreachable by your gateway. Gateway going to inform you. Destination host is unreachable. Might be network is present, but host is not on the same segment or may not connected or turn off. Destination protocol is unreachable. Maybe there is a IP phone, or let me go through some other example. There may be a IP camera, and you want to take the telnet of IP camera. Maybe your IP camera is not aware about telnet, how to respond with telnet or SSH, which means destination protocol is unreachable. On which protocol you looking for to contact to destination? Destination is not aware about that. So destination port and protocol. Protocols basically means what application you want to use, you can say, and then port may be blocked by firewall or maybe some other equipments. So ICMP itself going to inform you, you cannot access the destination device because of particular reason. So reasons are this: maybe defragmentation required, source route failed, destination network unknown, destination host unknown, host isolated, and so on and so forth. And let's see the ninth one. So it's going to inform you, suppose this is you and this is your ISP and there is another computer. So you send any message, it could be a telnet, it could be SSH or something else. The device is going to inform you that I am not working. It may be your device or it may be the gateway actually. That you cannot take the access of this device because of access control list prohibited you or denied your traffic, which is known as network administratively prohibited or host administratively prohibited. So sometime in ACL you can block particular host, node or particular network. So this is going to inform you why you are not able to connect with destination device. So this is use ICMP type of different codes and different types. So still some types and codes are reserved. If we go through the like 6, 7, 8 used for echo request, 9 used for router advertisement, and 10 used for router solicitation, 11 time exceed, and so on and so forth. And rest of from 24 to 255 are still reserved. Maybe in future some of RFC it going to define. So as we can see, so let us take example. If we want to take a telnet of we want to take a telnet of 8.8.8.8, which is Google public DNS server. We will get a error message, maybe 8.8.8 not working on port number 23, or maybe by ACL it going to denied. So that things now we come to know because of the ICMP. So you can see, so connecting 8.8.8.8 could not open connection to the host on port number 23. So now we come to know because of the ICMP, the destination is not working on port number 3. Similarly, rest of thing you can verify by emulating GNS or some other like VRIL or some other network simulator. So here I am going to use my physical device to show you how your device is sending reply back to the source if destination is not reachable, if destination port is not reachable, if destination network is not reachable by your gateway or some other problem. So let me turn on my devices and go through couples of configuration and verification. Alright, my devices is up and working. Here I am using 2960 of switches and 2901 of router. So switch 1 is going to work as a host, switch 2 is going to work as a actually hub. We'll discuss shortly how you can configure particular switch to perform frame flooding on every packet. And these are the routers. So first let's check the configuration of switch 1 and switch 2. On switch 1 I'm going to put some configuration which is I have already made up. So I'm going to copy on switch which is working as a host VLAN 1 and then IP address is 200.200.0.100 and then mask, no shut and then default gateway. So on switch 1 going to paste. On switch 2 which is working as a hub, which we need to configure so that it work like a hub, no MAC address table learning from VLAN 1 and interface range F0/1 to 2 and gig 1 to 2 switch port host, which basically means they are not going to generate any BPDU or spanning tree related messages, and their transaction will also going to become faster, transaction or a convergence. Now my switch 1 and switch 2 configured, and now it's time to configure my router. This is R1. So same configuration file I have already made it. This is actually R1, so it should be R1, which is actually a router branch. It's Control C for copy, and let me paste on branch. So that's good. Next thing which I'm going to use, I'm going to verify if I'm going to send any packet from host or switch 1 to our gateway. Your packet goes through the switch 2 and switch 2 going to forward out of every port, which technically known as frame flood. So before sending any message, I also going to start capturing. So this is the Ethernet interface which I am connected with, and by the way, in background I have a Wi-Fi connectivity. Over Wi-Fi connectivity I am connected with my terminal server, but this is not part of this video. That's why I'm not going to demonstrate all those things which is not relevant to this video. And let's send a packet to the destination. So ping, my gateway is 200.200.0.1. excuse me, it is 0.1, control shift 6. Hopefully I have some ICMP messages, yes. So let me discard this one. Actually this is we are not going to use this one actually, excuse me. uh, Wait, let me clear this off and launch it again on Ethernet. I need to ping 0.1. As we can see here, we get reply back. Let me uh, pause the capturing or sniffing the packet. The source IP address was 200.200.0.100, which is IP address of switch 1. If you use command so IP interface brief, you will find the VLAN IP address. And likewise, the IP address of gigabit 0/1 of R1. The destination IP address was 200.200.0.1. We get a reply back from the router, which is working as a gateway. Sorry, we can verify the type in codes. So type 8 used for echo, in code 0s basically, let me verify on the documents. Code 8 is echo request and 0 shows that we getting reply back. So similarly, what happens if we sending any packet which is not connected with the R1? What R1 going to respond as? So now R1 has a single interface which is up and working. We'll figure out the routing table. There is only directly connected network. But R1 going to send a packet which is not available in network. Meantime, I'm going to capture a new traffic. And now I'm going to ping 1.1.1.1, which is not in our network. We can see we getting message like unreachable, unreachable. This is the code or a character Cisco using so that the network administrator come to know the destination is unreachable. Likewise, we should also have these ICMP message. So ICMP message, the source was 200.200.0.100, which is our switch, and we sending that packet 1.1.1.1, and we didn't get any response. But now router going to tell us, which has IP address 200.200.0.1 to our switch, that is 200.200.0.100. This is type 3, that is destination unreachable, in code 1 is host unreachable. Let's verify whether it is correct or not. So type 3, destination unreachable, and then after what was that? It was code 1, the destination host unreachable. Likewise, every time while we send any not only with ping packet, let me generate the traffic using telnet. So I'm going to take telnet, not only ping, TELNET, telnet of 1.1.1.1. Again, the destination is not reachable, gateway says to us. And let's see, this is the TCP packets. Destination is unreachable. We get reply from the router. Router says that the destination is unreachable. So likewise, for rest of all, they're going to inform why the destination is unreachable. So in this video, now we come to know how ICMP use to inform us to particular problem. Destination is unreachable, or destination port is unreachable, or some other problems. Likewise, we can use some other things to verify, and let come with the example what I'm going to do. to verify. I'm going to create a loopback interface and enable telnet on R1, and I'm going to block by access control list. If the host is coming to take the telnet, it's going to block, means administratively prohibited. So on R1, interface loopback 0, and then after IP address 10.10.10.10 255.255.255.255. This is the interface. IP line VTY, let's see, 021, and then password will be CISCO login enabled. And then after I'm going to enable, first let it take a look which the telnet is enabled or not. So telnet 10.10.10.10. Yes, it is. So that's great. Now I'm going to apply an access list. So IP access list extended, this is 100. Deny TCP packets to anyone if they're going to host, which is 10.10.10.10, equal to port number 23, which basically means telnet. And rest of traffic are allowed. So permit IP any on interface v0/0 IP access group is 100, excuse me, and direction is in. Again I'm going to sniff out or capture the packet. So I'm going to take a new session to sniff out the packets. It may take a little bit time to clear off previous one. So meantime, let me write the destination IP address. Excuse me. I'm going to clear, and now take the telnet. Destination is unreachable. Type is 3 and code is 13, which means communication administratively filtered. We can see type 3 and 30, which is prohibited by access control list. So now I'm pretty sure you come to know the basic of ICMP types and ICMP codes. So based on their settings, based on the situation in network, they're going to inform you. In this video, I'm going to discuss only ICMP unreachable. In upcoming video, we will discuss redirect, fragmentation, and TTL.